Hello everybody, this is day 3 of solving differential equations. Today's focus is going to be what we call exponentiating both sides. Okay, so here is our derivative, here is our initial condition, and we have to solve the differential equation. So it's going to be the same 5 steps. Step 1, separate the variables. So we'll start off by cross multiplying, and we're going to get dy equals this mess, and we don't quite have the separation of variables just yet. We do have a y binomial over here, and we are going to have to divide it out. Okay, and I'm going to write it as 1 over 3 minus y dy, and then we have cosine x dx. So now we have true separation of variables. And step 2, we are moving ahead to integrating both sides. Okay. All right, so I'm actually going to start on the right hand side here. This is just the parent cosine function. So if we just review our sine cosine wheel to help us with derivatives and antiderivatives. Antiderivative is when we go in a counterclockwise direction, right? Derivatives is clockwise, but antiderivatives is counterclockwise. So the antiderivative of cosine is sine of x. Let's see. Okay. And now we go to the left side, which was what our focus was yesterday. If we analyze the degrees of the numerator and denominator, the degree of a constant is 0. And the degree down here is 1, right? The highest exponent we see on the variable y. And when we have that relationship where the degree of the denominator is 1 larger than that of the numerator, that is our trigger that the antiderivative is the natural log function, right? And as we saw yesterday, the u value is the denominator. But we always want to do a quick check to see if that's sufficient enough. So we are saying that if we find the derivative I should change this to y, excuse me. We are actually saying that if we find the derivative, that it should look exactly like this, right? And the derivative of a natural log is 1 over u times the derivative of u. So since we're in terms of y here, the derivative of 3 is 0. The derivative of negative y would be negative 1. And if we were to simplify that, we are going to see that our derivative is just a little bit off. It's off by a factor basically of negative 1. Right? If we multiply this by negative 1, we would get the positive 1 that we need. So that indicates that we have a negative 1 right there. Okay. Now, something that I didn't focus on yesterday, because I didn't want it to be too much at one time, is that technically we should instead of putting parentheses around the u value for a natural log function, we should put an absolute value symbol. And this is because, as a review from Algebra 2 and Pre-Calc, that, you know, if you did ln of, I don't know, let's just say -5, right? It's not a real answer. And that's because the graph parent graph, if you think about it, right, has a vertical asymptote at y equals 0, and the domain values are positive, right? So that's why your calculator is saying something like ln of -5 is an error, right? So we are supposed to put absolute value symbol to sort of note that whatever this is has to come out to be positive, okay? And again, I didn't emphasize that yesterday in our lesson, just because I didn't want to throw another review topic at you, you know, at the same time. Okay, so we have successfully integrated. Now we're on to step 3, which is to find the c value. So we were given an initial condition where x is 0 and the y is 1. So sine of 0 is going to wind up being 0. That's right off of the unit circle. Right, so this would be 0 or 2 pi radians. So we can see that at 0 radians, the sine value is 0. So I'll just put that in there for a placeholder. And then over here, we have -1 times the ln of 2. At this point, we no longer need the absolute value symbol for this particular step, because the absolute value of 2 is in fact just 2. So at that moment, you can drop it for your c value. Okay, and step 4 is to now solve for y. So let's go back to the end of our step 2. So we're right here. So our c value is basically minus ln of 2. Okay, so I'm definitely going to multiply the whole equation by -1. And I think I'm going to just reorder this over here, since both of these terms are going to be negated. I kind of like the way, I guess, that looks. All right, so our focus for this lesson is called exponentiating both sides. So we have to get y by itself, but it's sort of in this absolute value connected to this natural log function. So in a very similar way where you would square both sides or square root both sides or multiply by 5 on both sides, we can do something like this. We can exponentiate both sides. And we're going to use the base of e. Technically, you could use any base, but we would especially want to use the base of e here because e and ln are inverses of each other. So the equation that we had is really the exponents on both sides. And the reason why this is helpful is, well, we reviewed this shortcut yesterday. E to the x and ln of x are inverse functions. So in a very similar way, like if you had the square root of x squared, right? We know that the square and the square root sort of cancel each other out, and you're just left with x. Well, the e to the x and ln of x function are inverses as well. So the shortcut is that when we have this e to this ln situation, essentially you can cancel it out. And it's really just equal to what was next to the ln. In this case, the absolute value of 3 minus y. Okay. Now we have a situation over here. We're also going to bring in our knowledge from a couple of lessons ago. So we have e to the ln of 2 minus sine of x. This is all an exponent. And what we're going to do is we're going to rewrite it. Again, you had to do this in your lesson on Monday. And we understand that when we multiply like bases, we are adding the exponents. So I didn't do anything wrong here. I just rewrote this another way. And maybe you can see why I did that is we have another situation over here where we have e to the ln, right? So this really is just 2. No longer an exponent, it becomes the coefficient of e to the negative sine of x. Okay. Now, another review concept here is that when you solved absolute value equations, going back to Algebra 1, so let's just say you had this, right? Well, what can x be? Well, x can be plus or minus 3, right? If you think about it, the absolute value of 3 is 3. The absolute value of negative 3 is 3. So there was a plus or minus that occurred when you solved absolute value equations. So we're going to apply that here as well. So we can eliminate the absolute value symbol as long as we say that the solution on the other side could be positive or negative. And then we can subtract 3. Okay, and then we can multiply everything by negative 1. Okay, so when you take negative 1 and you multiply it by plus or minus 2, the plus or minus is going to remain. And the very simple reason is if you take negative 1 and you multiply it by positive 2, you get negative 2. And if you take negative 1 and you multiply it by negative 2, you get the positive 2, right? So the plus or minus still remains right there. But we do have to multiply negative 1 times negative 3, and that will change this to be plus 3, right? And this is where step 5 is really, really important for you to remember to do. Step 5 is to check the initial condition, and the initial condition for us was f of 0 equals 1. And what we're looking at here are two different possible answers. That one or this one. And we have to see which one it's going to be. In all of my years, you never keep both. So let's check it out. Let's check out which one works, right? So sine of 0, we saw earlier that it is 0. So we really are simplifying this, and I don't think that's going to work out. E to the 0 is 1. So we wind up generating this false statement here, right? 1 does not equal 5. So this is not the solution to this differential equation. If we come over here, sine of 0 is 0. E to the 0 is 1. And now we get a true statement. Negative 2 plus 3 is 1. So the official solution to this question is right here, right? So had we not remembered how to solve absolute value equations by making the solution plus or minus, right, we would never have been able to get what the appropriate answer is, because we never would have had that negative sign, right? So all of these various review topics, so important.